Hello and welcome to Data Sunrise demo of the synthetic data generator feature introduced in version 10.0 2024 year. So what is the purpose of this feature? How we can help you to achieve your goal for test data management? First of all, Data Sunrise provides you with some preset of generators for different purposes, and also you are free to create your own generators that may have different types, like composite data generator or some predefined values and so on. Let me show you what do we have in this release and how to generate data for a couple of related tables, like simple scenario. Now, under configuration menu item of Data Sunrise, you can find a new item called generators. Data Sunrise with each release provides you with new generators. So these generators are predefined, and I've created some of them manually by using Data Sunrise Web UI. Let me show that one of these settings, like IP address, this generator is predefined. You cannot change it, right? But you can create your own by using simple principles. You choose the generator type, then define different generator subtypes, and then combine them together if required. Let me show an example how I created last and first name value by using composite generator type. So there are different ways we can choose from lexicon, just single random value from a list, which we can upload to Data Sunrise, and Data Sunrise can use it randomly. But I used composite generator type, and I combined the lexicon called USA first names. Then I used the separator, which is in my case is just a space, and another lexicon called USA surnames. So these start and result length positions are connected to the principle that if we choose from the position number 1, then it depends how many positions we should take from the list of that particular generator. So in this case, according to the principle indicated here, that if the result length value is 0, then the full original value will be used. So the full length, full list of USA first names, and the same case is for USA surnames, the full list of all results lengths. So Data Sunrise will combine them randomly and provide them the combination of the first name, last name, separated by space. So this is one of the examples how we can create such a generator. Now, let's turn our attention to the way how we can create the data. So these are types, almost engine-independent generators or types of data we can generate. But in connection to the task itself, so when we need to generate the data physically, we need to create a new task and choose from the list synthetic data generator. So I've created already the one here called sales database, and as the name says, it's connected to the sales database in my PostgreSQL database instance. And I've selected here the database schema and names of these tables. And Data Sunrise, well, I recently chosen that, and Data Sunrise provided me with default generator for each name of the column, depending on the type of the data type, and depending on the name of the column. So this way, Data Sunrise tries to guess what do you mean when you select this particular table with this set of columns to generate some fake data, some test data. Now, for sure we can go and amend every single item here, but please bear in mind that if you mismatch the data type and the generator, the Data Sunrise will inform you that probably you do something wrong. Like, for example, the ID is the primary key. If we accidentally will choose from, let's say, the gender, right? Then Data Science will tell us, well, you are trying to do something wrong. The value doesn't match the data type. So now, if we choose the primary key, should be there somewhere. choose increment, right? Sequential number. Then datasets will use it for the primary key. The incremental will increase every time on each row. Now let's look inside of some of the columns that we used. Like here's the address line, and I used my own created random address line. So this address line is accessible from here, and since this is a custom generator, I can go ahead and choose it right away from the periodic task to synthetically generate the data. So as I see, I implemented the composite generated type, and I used several lexicons separated by comma, right? And this way, data science will provide us something like an address, which for sure will not correspond to any real address. Now, how we can manage how much data we need to generate, right? So this is again is connected to the number here. So we choose table, and then we set the number of rows required. But what if we need to join several tables, and one of them has a primary key, another one has a foreign key. In my case, this is orders table. So I'm going to use this as a foreign key. So it's defined in my table as a foreign key, which references to the ID in my customers. So this means data science will automatically detect that we have some kind of relationship between these tables, and will provide us with the foreign key generated type for the foreign key. Okay, now we see that I've chosen here to generate 5,000 rows for each table. So it will take maybe 5 to 10 seconds to generate these rows in my tables. In order to generate the data for the existing tables, we need to make sure that probably that the tables we used are empty. So then to make sure that that there is no other data, we can just delete or truncate these tables. There is such an option, truncate target tables. If required, to make sure that there is no data and stop on that. If that is not true, then we can check for empty target tables for each table. Right? I also can manage with the foreign keys, disable triggers if they are, right, so they exist. And it's important to skip tables generation if there is any error occur. Yeah. So if the error will occur, then data science will stop the process. It will generate some rows, but when any error will happen, then data science will stop the process. Since this is a periodic task, you can run it manually for sure, like I do, or you can choose the frequency of generation and choose some schedule, like let's say every hour starting from this time, and repeat it every 1 or every 2 hours, and so on. You can also remove the old results, right, just to keep it clean. Now let's check our tables. Let's make sure that we did not populate it with any data. So I go to my dbeaver application. So I have my sales database and my PostgreSQL database instance, and these are tables. So since I use this database, I select both, right? So when I execute the script, so everything was cleaned, and I'm trying to open up, then we'll see these tables are empty, right? So let's close them. Let's go back to our data sunrise, and let's just click this start now, because it's designed to run manually without any schedule, so I don't want to wait for any seconds or minutes. Now it's trying to insert table into table sales, customers. Oh no, 12 seconds happen. If we need to see some statistics or error messages, if they will be there, then we just click show, and data science will provide it with errors, different result sets, statistics about how fast does it insert the data into rows. Now let's go back to my dbeaver and see what data was generated. Let's click again, view data. Okay, so we see that the job titles here chosen, email addresses here, first and last name combined through the composite generator, and the phone number. Definitely it's a fake number, and an address line combined from different lexicons and some numbers and so on, that provide us with some non-existing addresses. Person ID, which could be a social security number, is here, or the state is like typed by abbreviation or maybe the full name of the state. They're all here. So if we choose, let's go, click here, orders, to see what's in there. So we see that the referential integrity is followed, and the custom ID is here. The order sum and the fake order date is here, so which is just like random data, random sum, random number, random date. So this way you can generate your test data and fulfill your goals with test-driven test management purposes. Thank you for watching.